Hello, welcome to this session. So, before we start our practical training in electronics, we are going to look at the software tools we are going to use for designing our electronic circuits. So, one of the tools we are going to use is QUCS or Quite Universal Circuit Simulator. So, I'll start. I'm going to show you how this tool looks like and what you can do with this tool. So I'll start by opening this tool. Now in this tool you find there are four tabs at your leftmost corner. So the first default tab will be the projects where you can see all your projects. You can create new projects, you can open existing project, you can delete a project which is not open. Then you have a content, that is you select a project and go for its content. So you see there are some contents in this. So if I go for resistor networks, so there will be some components. So when you find, if there are files in this, in any of these projects, then it will show it here. Then you come to the components. So in components you have got lumped components where you have got your RLC components, your filters, attenuators and so on. Then you have got sources where you have got DC voltage sources, AC voltage sources, current sources, so on. Then you have got probes. So there are only two kinds of probes. Either it is the current probe or a voltage probe. Then you have got transmission lines, non-linear components. So non-linear components are basically your semiconductor devices. And then you can construct Verilog code using QUCS. So you can, this Verilog is analog devices in Verilog. And then you have got digital components which can be converted to Verilog or HDL. And then you have got file component, that is components you have created before and we can use them as a in a hierarchical system. So we'll go more in detail in the file components as we proceed further, as we create complex circuits. Then you can simulate the circuits. You can choose the kind of circuits you want, the simulation you want for each circuit. Then you have got diagrams. So once you simulate, you can take out the a corresponding diagram to show the output of this simulation. So this is the structure of this QUCS. Now to start with, you can go to the insert menu and you see that you have got wire, you have got wire label. So each wire should have some name, and then you can insert an equation. You have to insert a ground is a very important and uh, vital component for your circuit. If there is no ground, your circuit cannot be simulated. You can insert a port whereby you can convert a circuit into a circuit block. You can set markers on the graph. So uh, um, these are the components of your circuit diagram which are available for you. They are available in your toolbar also. So you can choose wire, you can choose wire label, you can choose equation, you can choose ground, you can choose port, you can simulate. There are more tools available in the toolbar. So this is the thing you have got. So with this it is fairly easy to start a project. So supposing I want to start a project, I go to the project folder tab and click new. So I will name my project as I'll call this my first project. I'll call this my first project. And I click the button create. Now you see I got it goes to the content tab and you have a untitled schematic page available for you for each project. So we can start by going to the component library. So I'll start with this simple resistor network. So you find two symbols for resistor. One is the global symbol and the one that is used by US or what is known as the ANSI symbol. You can use either of these. So I'll choose the global symbol and once I click the symbol will follow my cursor. It will place the symbol wherever I click on the schematic page. And if I want to change the position, I right click, I click the right button of my mouse and it rotates by 90 degrees. And these points are the grid points. So it is easy to position the component. So you can position this by left clicking your mouse button. Now you are ready to fix one more resistor. Let us assume that we will construct a very small resistive circuit. So I will add one resistor parallel to this circuit, to this R2. So this is my resistor circuit. Now to stop adding resistors, you have to click escape or this mouse button. So I click escape on the keyboard. Now I escaped the adding of resistors. Now I am going to add a source. So I go to the component drop down. I select source and I select a simple DC voltage. Now a DC voltage sign it follows my cursor. I position this cursor, this DC voltage source here. I can set the voltage. I just click on U equal to 1V and so I will get this edit property window. I can also choose it by right clicking the component. I select the component and right click and edit component. So it's set at 1 volt. Let us change this to, let us say, 5 volts. You click apply and OK. You can also change the values by directly changing the value on the circuit board. So I will change this to 1k ohm and similarly I will select R2. So I will select only the 50 in the 50 ohms. I add 1k. I can select edit properties and I can change 50 ohms to 1k. Apply and OK. So we have set the circuit components. Now it's time for the ground symbol. So I select the ground symbol and I bring it down. So I can position a ground symbol at one point or I can have ground symbol at different points. It does not alter the circuit. So this is a single ground point. No matter how many instances you copy, it is only one ground point. Now we are going to start wiring this circuit. So you see, I can use Control L for layer, Control E for wires. So either I can go to the menu, or I can go to the toolbar, or I can use the keyboard shortcut Control E. When I select this Control E, your cursor has got a huge crossbar with cross crossbar um, uh, with your cursor. Now you can drag from one point to the another point. Now you find that the angle of this line is not correct. You will want it to shift to the other side of the rectangle. It is very easy. You click right mouse button and it will change the direction. And you click at the point for the connection. Now the connection has been completed. You come back to your crosswire uh, cursor. Like this, I complete the circuit. So we have completed the circuit. I have made some mistake. So this should be like this. Like this. I'll pull this. So if you pull the components come but the connections remain. Like this. I can pull the wires also. Now I want to check the currents through all these branches. So I will name the branches. I will go to name, or in insert I got this wire label. I can even use Control L for this. So I will select wire label. Now you find this cursor as as some added graphics. So you click on the wire. I'll call this, let us say, A. So this wire is labeled A, and I will call this wire a label B, and then this as C. So I have, okay, so this is the junction. Either you name it here or here. And now you can go to the simulation. You want to know what will be the voltages in this point. You go to simulation. You select DC simulation and position it anywhere in the schematic page. So the position of this DC simulation is not important. It's only important that you have the simulation in the schematic page. Now you can run the simulation. It's as simple as this. So now it will run the simulation. So I have to save my file. So I'll save this file as, say, let us say we are looking at KVL, Kirchhoff's voltage law. So if there is any error in your circuit, it will list the errors, and if there are no errors, it will take you to another page called KVL DPL. where you can use one of these diagrams. Right now I'll use the tabular diagram because there is not much of data to show. So I have got B and I have got the input current from the voltage source. So this is the voltage I have got. Now let's take this problem a bit further. Assume that I want to know the current in each of these branches. Then I'll have to have some space for a current probe. I pull these resistors a little bit down so that there is space for current. I'll also pull down this. Okay. Now I'll remove this label, or I'll have this label here. Now what I'm going to do is I'm going to go to the probes, and before that I will remove these connections. I will have a current probe selected. Now we can have a voltage source because we are studying Kirchhoff's voltage law. You can have this like this. So voltages you are going to measure across the component. So you select a voltage probe, you rotate it so that it is facing the component. Let us have one more voltage source. I'll just copy this. Right click, copy and paste. I'll have one voltage source here. So now I will use Ctrl E to start wiring this voltage source. So this voltage is measured between the terminals of R1, and this between the terminals of R3. I'll take a minute to change this R2 and R1 values. So it's going to be 1K. I type the 1K and click enter. Say I'll do the same thing to R1 also. I will add 1K and click enter. Now I will run the simulation. This DC simulation is already available in the page. You don't have to put another DC simulation. Just update the circuit by clicking your simulation. So it will display a message about the simulation process. Now we have removed B, so there is no data. We'll right click this figure. We'll take out B. You can delete this graph. You can. Now we can add probe 1 and probe 2, and I can even, so I can apply and click OK. So this is the, so add this, you get your Kirchhoff's voltage law. So are you satisfied with this? Now supposing I want to uh, have a Kirchhoff's current law, I can open one more page. I can open another page like this. I can go here and select all of this. I will select all of this by pulling a window across and Control C, and then I come to this untitled schematic page and Control V. So you have the entire thing. Oh, so you have the entire thing ready. No, I don't want the voltage probes, so I will remove the voltage probes and the associated wiring with it. When you select the delete command, you will have this X displayed on your. So you just take the cursor and click your left mouse button to delete whatever you want. Now we go to the wire command and we add some wires. So you can shift the direction of the wire by selecting the right mouse button. Now I am going to go to the probe. So before I go to the probe, I'll remove these wires. I'll remove this wire. I go to the probes and I select a current probe. So current probe is always added in series with this with the component. So I will position it. So we decide on the direction of the current. So the current is going from the higher potential to the lower potential. So I will position it in such a way. Now I will complete the wiring on the main branch. So now I'll delete these wires. So I need space for using a current probe. So I'll select this current probe, copy and make one probe for R2 and another probe for R1. Now I complete the circuit wiring like this. So it's complete. Now I need a DC simulation for this page. So I go to the simulations. I select DC simulation. Now if I run DC simulation, so I can even use keyboard shortcut of F2. Now I will have to save this schematic page, so I will call this KCL and save this. So I can again have a tabular a diagram. So I'll select a tabular diagram. Now I have got PR1 current, PR2 current and PR3 current. So this is your branching. So you find that KCL or current Kirchhoff's current law is also holding good. So the currents through PR3 and PR2 will be equal to PR1. Let's change one of these values. I'll change this to let us say 2K or 2.2K. Now let us see what happens. We run the simulation again by clicking F2 on the keyboard. Sorry. Now you see that this is the, so yes, you add this and you get this. You add PR2 and PR3 currents, you will get PR1 current, right? So it is to exact to 1, 2, 3, 4, 5 decimal points. So, so you see it's very easy to use QUCS. So I demonstrated a very simple and very basic circuit to demonstrate that uh, laws as basic as Kirchhoff's voltage law and Kirchhoff's current law can also be simulated and tested here. So thank you for watching this session. So this should have given you a fair idea of how QUCS 0.0.18 will look and feel and how to work with it. So with this we start working on different aspects of training in electronic. So first we design our circuit using a software, and then once the design is through is correct, we proceed to fabricate the circuit in real time. So this is going to be the content of our course. So at each point you may have to work out on some projects. Thank you for watching this session. Thank you again. See you. See you in the next session.